Good morning, ma'am. This is M. Ashwita from Computer Science and Engineering Department. Today, I am here to explain about shift registers regarding digital logics and computer organization. Outline of my presentation. Introduction to shift registers, types of shift registers, serial in, serial out shift register, serial in, parallel out shift register, parallel in, serial out shift register, parallel in, parallel out shift register, bidirectional shift registers, universal shift registers, shift register operations, applications and advantages of shift registers, and final conclusion. First, introduction to shift registers. Shift registers is a group of flip-flops used to store multiple bits of data. The bits stored in such registers can be made to move within the registers and in or out of the registers by applying clock pulses. An n-bit shift register can be formed by connecting flip-flops where each flip-flop stores a single bit of data. The registers which will shift the bits to the left are called shift left registers. The registers which will shift the bits to the right are called shift right registers. What is a shift register? A shift register is a series of flip-flops connected in a chain allowing data to be shifted in and out. Each flip-flop holds one bit of data, enabling the storage of multiple bits in a single register. Shift registers can be classified into different types based on their operation and data handling. Types of shift registers. Shift registers are basically of following types: serial in, serial out, serial in, parallel in, serial out, parallel in, parallel out, bidirectional, and universal shift registers. Each type serves different purposes such as data storage, data transfer, or data conversion. Understanding the differences helps in choosing the right shift register for specific applications. Let's see the type one by one. First one, serial in, serial out, that is also called as SISO. The shift register, which allows serial input one bit after the other through a single data line and produces a single serial output, is known as a serial in, serial out shift register. Since there is only one output, the data leaves the shift register one bit at a time in a serial pattern. Thus, the name serial in, serial out shift register. This is the block diagram of serial in, serial out shift register. Next, serial in, parallel out. The shift register which allows serial input, that is one bit after the other through a single data line and produces a parallel output, is known as the serial in, parallel out shift register. The logic circuit given below shows a serial in, parallel out shift register. Next, parallel in, parallel out. The shift register which allows parallel input, that is data is given separately to each flip-flop and in a simultaneous manner and produces a serial output, is known as a parallel in, serial out shift register. The logic circuit given below shows a parallel in, serial out shift register. Parallel in, parallel out PIPO. The shift register which allows parallel input, that is data is given separately to each flip-flop and in a simultaneous manner and also produces a parallel output, is known as parallel in, parallel out shift register. Bidirectional shift register. If we shift a binary number to the left by one position, it is equivalent to multiplying the number by 2, and if we shift a binary number to the right by one position, it is equivalent to dividing the number by 2. To perform these operations, we need a register which can shift the data in either direction. Bidirectional shift registers are the registers that are capable of shifting the data either right or left depending on the mode selected. If the mode selected is one, that is high, the data will be shifted towards the right direction. And if the mode selected is 0, that is low, the data will be shifted towards the left direction. Universal shift registers. Universal shift register is a type of register that contains both right shift and the left shift. It has also parallel load capabilities. Generally, these types of registers are taken as memory elements in computers. But the problem with this type of register is that it shifts only in one direction. In simple words, you mean that the universal shift register is a combination of bidirectional shift register and the unidirectional shift register. Shift register operations. Shift registers perform three main operations: shift left, shift right, and parallel load. Shifting left or right moves data bits to adjacent flip-flops, while parallel load allows multiple bits to be loaded at once. These operations play a critical role in data manipulation and storage in digital circuits. Applications of shift registers. Registers are widely used in digital communication systems for data serialization and deserialization. They are essentially components in memory devices, allowing for efficient data storage and retrieval. Additionally, shift registers find applications in digital signal processing and control systems. Advantages of shift registers. Shift registers provide efficient data handling, reducing the complexity of data management in circuits. Their ability to handle multiple bits simultaneously enhances overall system performance. Shift registers also simplify the design of digital communication interfaces. Conclusion. Shift registers are fundamental components in modern digital electronics, enabling efficient data manipulation. Their diverse types and applications make them essential for a wide range of technological advancements. A thorough understanding of shift registers is crucial for anyone working in electronics and digital design. Thank you, ma'am. This is presented by Ashwita from Computer Science and Engineering Department.